Dear students, welcome to this online class. How are you? I hope that you all are fine and safe at home. Have you studied your portions? Hope that you started your revision for your pre-midterm exam. Okay, today's our topic is Real Numbers, Chapter 1. In our earlier classes, we have learned about number line and the representation of various types of numbers like natural numbers, whole numbers, integers, and rational numbers. In this chapter, we will study the another set of numbers which are known as irrational numbers and its representation on the number line. Also, we will study the decimal representation of rational and irrational numbers. Let us first revise the representation of various types of numbers on the number line. The numbers we are using for counting. So, all counting numbers 1, 2, 3, etc. are known as natural numbers. So the first set of numbers is natural numbers. They are 1, 2, 3, etc. The first and the smallest natural number is 1 and there is no last number. It's continuous endlessly or it is infinitely many numbers in that set. It is represented by the letter capital N. Represented by the natural numbers are represented by the letter capital N. It is written as set of natural numbers. N is equal to. The set of natural number is written as N is equal to 1, 2, 3, etc. And next set of numbers is if we include 0 to this set, we will get whole numbers. The collection of natural numbers along with 0 is known as whole numbers. Whole numbers are represented by the letter W. It is written as 0, 1, 2, 3, etc. So, smallest whole number is 0. So, we see that the collection of natural numbers and 0 is known as whole numbers. So, all natural numbers are whole numbers. The next set of numbers are integers. The collection of whole numbers and negative numbers are called integers. The representation of integers or the collection of integers are represented by the letter Z. So it is written as Z is equal to the set of negative numbers, whole numbers and the natural numbers, etc. We know that the first set of numbers are natural numbers. Then 0 is included in this group. So we got another set that is whole numbers. The natural numbers, whole numbers and negative integers. They all together another family that is integers. That is represented by the letter Z. So here the numbers, natural numbers 1, 2, 3, etc. And whole numbers it will be 0, 1, 2, 3, etc. In integers, negative numbers, whole numbers and natural numbers. Altogether it is integers. Then also you can see some more numbers are in the number line. The numbers like 1 by 2, 3 by 4, 0.5, 0.25. Such numbers will be again left there. That is the fractions and the decimals. So that group, they are not integers. That is another set of numbers. That numbers also included in this group. So we will get another set, that is rational numbers. The numbers which can be written in the form of P by Q, such numbers are called the rational numbers. When in earlier class in 8th standard, we have studied about the rational numbers. So the numbers which all are including in this group, that is 1 by 2, 3 by 4, minus 0.5, 0.75, etc. So that means they are fractions and a decimal, that all are included in this group. So we will get another set of group there, that is known as rational numbers. It is representing by the letter Q. Rational numbers are representing by the letter Q. So all natural numbers are rational numbers. All whole numbers are rational numbers. All integers are rational numbers. And that means rational numbers includes natural numbers, whole numbers and the integers. That big family is known as rational number. So we know that rational numbers are the numbers which can be written in the form of P by Q, where P and Q are integers and Q not equal to 0. Here, the first case 3 by 4, it's a rational number. It is in the form of P by Q, where P is equal to 3 and Q is equal to 4. Both are integers. P and Q are integers and Q not equal to 0. That is the condition. Here, Q is equal to 4. It's not equal to 0. So what happened if it is 0? Suppose that integer Q is equal to 0. So what will happen? It will be 3 by 0. 3 by 0 is undefined term. So that's why its condition is given like this. Q not equal to 0. Look at the next example. Minus 7. Is it a rational number? Yes, it's also a rational number because this negative 7 we can write it in the form of P by Q. That is negative 7 we can write minus 7 by 1. The minus 7 by 1 is equal to minus 7. So it will be in the form of P by Q, where P is equal to minus 7 and Q is equal to 1 and Q not equal to 0. So this is also a rational number because we can write this in the form of P by Q. And look at the next number 0. Is it a rational number? Yes, because we can write 0 by 1. 0 by 1 is equal to 0. Any 0 can be divided by any using any number. So 0 by 1 is equal to 1. Sorry, 0. So it's also a rational number. The next number is 0.5. Is it 0.5 is a rational number? Can you write it in the P by Q form? Yes, we can write this decimal, change it to fraction, then it will be 5 by 10. 5 by 10 is a rational number because it's in the form of P by Q. And now it is not in the lowest form. You can write the lowest form, that is 1 by 2. So here P and Q are integers and Q not equal to 0. That means P and Q are co-prime numbers because these two integers P and Q have only 1 as a common factor. There is no other common factor other than 1. Such numbers are called co-prime numbers. So now we can say this is in the standard form. See the next number 2. 2 is an integer. Is it a rational number? Yes, because we can write this 2 in the form of 2 by 1, that is in the form of P by Q. So 2 is also a rational number. And the next number is minus 1 by 4. It's already in the form of P by Q form. P and Q are integers and Q not equal to 0. Therefore, it's a rational number. So we can say that a number which can be written in the form of P by Q and P and Q are integers and Q not equal to 0. Such numbers are called the rational numbers. So we understood all integers are rational numbers. Then every rational number is an integer? Is it? No. Because 3 by 4 is a rational number, but it is not integer. The collection of integers, only positive integers, negative integers and 0. That all come under this integers group. That means positive numbers, negative numbers and 0. But 3 by 4 is a fraction. It's not included in integers. So all real numbers are not integers. When you represent rational numbers on the number line, we can represent all integers on the number line, and the same way we can represent minus 5 by 2, we are able to represent 1 by these all we studied in the earlier classes, how to represent rational numbers on the number line. So the position of 1 by 2 is between 0 and 1, and minus 5 by 2 is between minus 3 and minus 2. So this way we are able to represent rational numbers on the number line. So all integers are rational numbers, but all rational numbers are not integers. Then the numbers which are not able to, or which cannot be written in the form of p by q, such numbers are called the irrational numbers. The numbers which cannot be written in the form of p by q, such numbers are called the irrational numbers. For example, root 2, root 3, root 5, etc. and value of pi. These all are irrational numbers. Root 2, root 3, root 5, etc. are known as irrational numbers. We know that the root is representing a positive root. The root means it has two numbers. If it is root 4 means it has two roots, positive 2 and minus 2. But if you represent this sign, it is representing only the positive integer. So these all are known as irrational numbers. These numbers we cannot write it in the form of p by q. And the numbers like 0.101, 011, 0111, etc. These all are known as irrational numbers. These numbers we cannot write it in the form of p by q. The value of root 2, if you take the value of root 2, it is 1.414, like that it's going endlessly. So such numbers we cannot write it in the form of p by q, or we cannot write it in the fraction form. So such numbers are called the irrational numbers. So first we studied rational numbers. Now we get another set of numbers, that is irrational numbers. The collection of all rational numbers and irrational numbers together make up the collection of real numbers. So the collection of irrational numbers and rational numbers are known as real numbers, which is denoted by the letter R. Therefore, a real number is either rational or irrational. So we can say that every real number is represented by a unique point on the number line. Also, every point on the number line represents a unique real number. That's why we call the number line the real number line. Next, our topic is rational numbers between two rational numbers. For example, find 5 rational numbers between 1 and 2. You should find the rational numbers between 1 and 2. At least 5 rational numbers you find between 1 and 2. We know that there is no integers between 1 and 2. But there are many rational numbers between 1 and 2. So finding this, first of all, you should write these numbers in the fraction form. 1 we can write it as 1 by 1. Now it is in the P by Q form. And 2 we can write it as 2 by 1. We need 5 rational numbers. So multiply the numerator and denominator of these numbers by more than 5. That means 5 plus 1 or more than that. At least 6 or more than 6 you have to take to multiply the numerator and denominator of these fractions. So if you multiply with the 6, because we need 5 rational numbers, so 5 plus 1, 6 you have to consider. So if you multiply by 6, the fraction you will get the equivalent fraction of that, or equivalent rational number you will get, that is 6 by 6, and here it is 12 by 6. Now you can see that between 6 by 6 and 12 by 6 there are a lot of numbers. See, after 6 by 6 there will be 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. There are 5 rational numbers are between these two numbers. We know 6 by 6 is 1. 12 by 6 is 2. So between 1 and 2 there are 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. There are 5 rational numbers we got between 1 and 2. Same way, if you multiply with more than 6, you will get more number between this 1 and 2. Let's see. Suppose you are multiplying between more than 6. You can multiply by 8. Then 1 by 1 into 8 by 8, that is equal to 8 by 8. 2 we can write it as 2 by 1. So multiply by 8. Then it will be 16 by 8. So between 8 by 8, there is next number 9 by 8, 10 by 8, 11 by 8, 12 by 8, 13 by 8, 14 by 8, 15 by 8, next 16 by 8. So between 8 by 8, there are lot of rational numbers. That is 9 by 8, 10 by 8, etc. So we know that 8 by 8 is equal to 1, 16 by 8 is equal to 2. So between 1 and 2, there are 1, 2, 3, 4, 5, 6, 7 numbers. 7 rational numbers are there. 10 by 8, 11 by 8, 12 by 8, 13 by 8, 14 by 8, 15 by 8. These also we studied in the earlier classes. So anyway, let us revise once more. So if you multiply more with more numbers, you will get more number of non-rational numbers. That means that there are infinitely many rational numbers are between any two rational numbers. So there are infinitely many rational numbers are between two rational numbers. Let us see the next question. Find 5 rational numbers between minus 2 by 3 and 1 by 4. Here minus 2 by 3 is a rational number and 1 by 4 is also a rational number. Both are in the form of P by Q and Q not equal to 0. We want to find 5 rational numbers between these two numbers. For that, first of all, you make the denominator same. Then you find the equivalent fractions. So here, minus 2 by 3 and 1 by 4, the LCM is 12. So make the denominator same. So minus 2 by 3 into 4, we will get minus 8 by 12. And next to 1 by 4. 1 by 4 into 3. So you get 3 by 12. So we got the denominator same. Using LCM you can multiply, then make the for making the denominator same. Now look at here, this is minus 8 by 12 and this is 3 by 12. Let's see whether there are 5 rational numbers between this minus 8 and 3. Minus 8 by 12. Then after the number minus 8 by 12 is smaller than minus 7 by 12. It is smaller than minus 6 by 12. It is smaller than minus 5 by 12. That minus 5 by 12 is smaller than minus 4 by 12. That is smaller than minus 3 by 12. That is smaller than minus 2 by 12. That is also smaller than minus 1 by 12. That is smaller than 0 by 12. Again, it's going like that. So, more than 5 rational numbers you can see between these two numbers. So, if we get a number like this, first you have to make the denominator same. Then check it whether there are enough number of rational numbers. How much you are asking to you, check it whether there are enough number of rational numbers. Otherwise, you can multiply the numerator and denominator with the same number and find the equivalent fractions. Then you can find out. So here you can choose any 5 of them. If there are a lot of numbers between minus 8 and positive 3. There are a lot of numbers are there. So you can choose any 5 rational numbers between these. Let us see the next question. Find 5 rational numbers between 2 by 5 and 3 by 5. Here 2 by 5 and 3 by 5. Between 2 by 5 and 3 by 5, now there is no other numbers. We cannot see a rational number between these two now. But if you write the equivalent fraction of this, you will get a lot of rational numbers between these two. So we need 5 rational numbers. So you have to multiply the numerator and denominator by more than 5. So here you can multiply 2 by 5 into, you can take 6 or 7, 8, whatever, the more than 5 you have to take it. So if you take more than 5, it will be, you can choose any number. Let us choose 7. That will be equal to 14 by 35. And 3 by 5 into same number, you can use 7 by 7. So 3 7s are 21, 5 7s are 35. So between 14 and between 21, there are a lot of numbers. 16, 17, 18, 19, 20, such numbers will be there. So you can write here 14 by 35. Next 15 by 35. Next 16 by 35. Next 17 by 35. 18 by 35. 19 by 35. Next 20 by 35. Next 21. Between 21 and 14 there are 1, 2, 3, 4, 5, 6 numbers are there. We need only 5 rational numbers. So you can choose any 5 rational numbers between these two. So 14 by 35, that is the equivalent fraction of 2 by 5. So we can write the answer like this: 2 by 5. Between 2 by 5 and 3 by 5, the numbers 15 by 35, 16 by 35, 17 by 35, 18 by 35, 19 by 35, 20 by 35. You can put the sign, greater sign. So here 6 numbers are there. You can write any 5 rational, choose any 5 rational numbers and write.
Dear students, now you take your Maths notebook, take the new page and draw the margins and write the chapter name real numbers. Then write down the notes. What are natural numbers, whole numbers, integers, rational numbers and irrational numbers. Last you can write what are real numbers. So dear students, today's your worksheet is exercise 1.1. So you should read your textbook and complete the exercise 1.1. You should write the worksheet in your notebook itself. Thank you.